Now, let us consider the second method. Under this method, which we call as transformation of variable techniques. So, let us try to see what is the transformation of variable technique for the discrete case. So, in this case we try to directly find out what is the probability mass function of y. So, let x equal to x1, x2, xp be a discrete random variable with support Sx and probability mass function Fx. Let gi from Rp to R I is equal to 1 to k be k given functions, and let yi is equal to gix for I is equal to 1 to k. So, each gi gives me a random variable yi. So, that means there are k random variables y1, y2, yk, each of them is a function of x1, x2, xp. So, in this case what would be the support of y? It would be collection of all those y belonging to Rk, such that y is same as g1x, g2x or gkx for some x belonging to Sx. So, this would be a support of y. So, that is why I am defining as phi like this. Also, for each y is equal to y1, y2, yk belonging to Rk, define ay is collection of all those x belonging to Sx, such that g1x less than or equal to y1, gkx less than or equal to yk. This would be useful when we find the distribution function of y, because when we find the distribution function of y, that is a certain probability, and that probability I will have to sum the probability mass function over a desired range, and this is the desired range for finding the distribution function. Now, if I have to find the directly probability mass function, then I have to sum the probability mass function over the desired range for y is equal to y, which would be by collection of all those x belonging to Sx, such that g1x is y1, gkx is yk. Then the random variable y is of discrete type with support Sy. Its distribution function would be given by this fyy, which is summation x belonging to ay fxx y belonging to rk. Because fyy is probability that g1x less than or equal to y1, gkx less than or equal to yk. So, that means I have to sum the probability mass function over this range, probability mass function of x. So, probability mass function of this I am summing over this range, which is g1 x less than or equal to y1, gkx less than or equal to yk, which is nothing but the set form. So, I am just summing over it and I get the distribution function. Similarly, to get the probability mass function fyy, which is probability that g1x is equal to y1, gkx is equal to yk. This is again a probability concerning random vector x. So, I will have to sum the probability mass function of x over this range, and this range is nothing but by. So, that is what the next assertion says, that probability mass function would be fyy, which is summation x belonging to by fxx y belonging to rk. So, one can find out distribution function and probability mass function just by summing the probability mass function of fx over the desired range. So, to see this, let x1 and x2 be IID random variables with common PMF given by this. So, that means they are independent and identically distributed. Since they are identically distributed, both of them have the same PMF, which is given by this. Now, here theta belonging to 0, 1 is a parameter. Let y1 is minimum of x1, x2, and y2 is maximum of x1, x2 minus minimum of x1, x2. So, in the first part you have to find the marginal PMF of y1 without finding the joint PMF of y1, y2. In the second part you have to find the marginal PMF of y2 without finding the joint PMF of y1, y2. Third part says find joint PMF of y1, y2, and fourth part says are y1 and y2 independent. Then using third part where you have to find the joint PMF of y1 and y2, find the marginal PMFs of y1 and y2. So, note that the joint PMF of x1, x2 would be f of x1, f of x2, because x1 and x2 are independent. So, that is why the product, and they have identically distributed, they are identically distributed, that is why the same f is coming. So, f of x1 into f of x2. If you do that, it turns out to be theta square 1 minus theta to power x1 plus x2 minus 2. If x1, x2 belongs to n cross n, which is set of natural numbers, 0 otherwise. Now, y1 is minimum of x1 and x2. Now, x1 can take any value from 0 to infinity with positive probability, y2 can take any integer value, positive integer values with positive probability. So, minimum would also be taking value from 1, 2 and so on, because x1 takes value 1 to 3, x2 takes value 1 to 3. So, minimum can be 1 to 3 with positive probability. Now, for y belonging to sy1, let us try to directly see what is the probability mass function of y. So, probability of y1 is equal to y, which is same as probability minimum of x1, x2 is equal to y. Now, I do not know which one is bigger, x1 is bigger or x2 is bigger. So, I apply the theorem of total probability on this event. So, theorem of total probability would be breaking it into 3 parts, where x1 less than x2, x1 is equal to x2, or x1 is greater than x2. So, probability minimum x1, x2 is y, x1 less than x2, probability minimum x1, x2 is y, x1 is equal to x2, probability minimum x1, x2 is equal to y, and x1 greater than x2. Now, note that in this case, because they are IID, so x1, x2 has the same distribution as x2, x1. So, that means over here, if you replace x1, x2 by x2, x1, you get the same probability. When you replace here x1, x2 by x2, x1, so minimum of x1, x2 would be same as minimum of x2, x1. So, this remains same, minimum of x1, x2 is equal to y. But here it would become x2 greater than x1, which is same as this. So, that means the last term is same as the first term. So, that is why this would become 2 times probability minimum x1, x2 is y, x1 less than x2, plus minimum x1, x2 is y, and x1 is equal to x2. Now, here x1 is less than x2, so minimum of x1, x2 has to be x1. So, this is same as 2 times probability x1 is equal to y, and since x1 is y, so this would be same as y less than x2. Then here minimum of x1, x2 is y, but x1 is same as x2. So, minimum of x1, x2 would be same as x1 or x2. So, this is same as probability x1 is y and x2 is equal to y. Now, here x1 and x2 are independent. So, this probability would be same as 2 times probability x1 is equal to y multiplied by probability x2 greater than y. Again, here x1 and x2 are independent. So, this would be same as probability x1 is equal to y multiplied by probability x2 is equal to y. So, probability x1 is equal to y is theta times 1 minus theta to power y minus 1. Probability x2 greater than y. So, that means I have to sum the PMF of x2 over this range, which is x equal to y plus 1 to infinity. Probability mass function of x2 is theta 1 minus theta to power x minus 1. Probability x1 is equal to y is theta times 1 minus theta to power y minus 1. Probability x2 is equal to y is also theta times 1 minus theta to power y minus 1. So, this quantity turns out to be this. Now, you can sum it. This is 2 theta square 1 minus theta to power y minus 1. This theta has come over here to make it theta square. Now, this is a geometric series whose first term is 1 minus theta to power y and common difference is theta. So, the sum would be this quantity plus theta square 1 minus theta to power 2 y minus 2. Simplify it by combining the terms, you get this as theta times 1 minus theta to power 2 y minus 2 times 2 minus theta. So, this is for y belonging to n, which is same as support of y. So, the PMF of y would be this if y belongs to sy and 0 otherwise. So, that is what you get. Now, let us try to find out the PMF of y2. y2 is nothing but maximum of x1, x2 minus minimum of x1 and x2. So, clearly here support would be because maximum of x1, x2 would be always greater than or equal to minimum of x1, x2. So, support would be 0, 1, 2 and so on. So, for y belonging to S of y2, probability y2 is equal to y is same as probability maximum minus minimum is equal to y. So, again here I apply the theorem of total probability on the ordering of x1, x2. So, probability x2 minus x1 is y, x1 less than x2, because here x1 less than x2 would force maximum to be x2 and minimum to be x1. Plus, when x1 is same as x2, then maximum and minimum are same. So, maximum minus minimum would be same as 0, 0 is equal to y. Then x1 greater than x2, in this case maximum is x1 minus minimum is x2 is equal to y. Now, again here I use the fact that x1, x2 has the same distribution as x2, x1. So, that means here if I replace x1, x2 by x2, x1, the probability does not change. But if I here replace x1, x2 by x2, x1, I get the first term. So, that means this term is same as this. So, that is why here you get 2 times probability x2 minus x1 is equal to y, x1 less than x2 plus probability 0 is equal to y and x1 is equal to x2. Now, 0 is equal to y either happens or it does not happen. So, that is why I consider a case first when y is equal to 0, when in which case this is a sure event. So, probability y 2 is equal to y, in this case what would be this? Probability, this says x 2 minus x 1 is 0 and x 1 less than x 2. That cannot happen. So, this probability would be 0, because x 2 is equal to x 1 and x 1 less than x 2 cannot happen simultaneously. So, this probability is 0 and this always happens. So, this same as probability x 1 is equal to x 2. Now, probability x 1 is equal to x 2 is same as summing the PMF over the desired range. So, summation x equal to 1 to infinity, probability x 1 is equal to x, x 2 is equal to x. Now, I know probability x 1 is equal to x and x 2 is equal to x. Because of independence, this would be same as probability x 1 is equal to x multiplied by probability x 2 is equal to x. Each of them would be same. Probability x 1 is equal to x is same as probability x 2 is equal to x, and each of them is theta times 1 minus theta to power x minus 1. So, the product would be this quantity, which is again a geometric series. You can sum it. The first term here is 1 and common difference is 1 minus theta square. So, this turns out to be this, which is same as theta upon 2 minus theta. So, this is for y is equal to 0. For y belonging to 1, 2 and so on, the second term would be 0, because if y is 1 to so on, this can never happen. So, this will never contribute. So, only this term will contribute. So, for y is equal to 1 to so on, probability y 2 is equal to y would be same as the first term, which is 2 times probability x 2 minus x 1 is equal to y and x 1 less than x 2, which is same as 2 times probability that x 2 is equal to x 1 plus y and x 1 less than x 2. But note that here y is always greater than or equal to 1. If y is greater than or equal to 1, then x 1 plus y is always bigger than x 1. So, that means if this happens, this is always guaranteed. So, that means this event implies this event. So, that is why their intersection would be same as probability x 2 is equal to x 1 plus y. So, here now I apply the theorem of total probability on the values of x 1. X 1 can take value x, where x is from 1 to infinity. So, this is 2 times x summation x equal to 1 to infinity, probability x 2 is equal to x 1 plus y and x 1 is equal to x. Now, here x 1 is same as x. So, I can make here x 1 as x. So, this probability becomes 2 times summation x equal to 1 to infinity, probability x 1 is equal to x and x 2 is x plus y. Now, they are independent. So, this would be same as probability x 1 is equal to x, probability x 2 is equal to x plus y. Probability x 1 is equal to x is theta times 1 minus theta to power x minus 1, x 2 is equal to x plus y is same as theta times 1 minus theta to power x plus y minus 1. So, if you multiply the two quantities, you get this, which is again a geometric series. You sum, you get this quantity, which is same as this. So, I found out the probability mass function of y 2. So, what is the probability mass function of y 2? This is theta upon 2 minus theta if y is 0, 2 theta into 1 minus theta power y upon 2 minus theta if y is from 1 to so on, and this is 0 otherwise. Now, let us consider the joint probability mass function of y 1 and y 2. Note that y 1 was minimum of x 1 x 2, y 2 is maximum of x 1 x 2 minus minimum of x 1 x 2. So, if you look at here, you get minimum of x 1 x 2 is same as y 1, maximum of x 1 x 2 is same as y 2. And I know that minimum and maximum both can take value which are positive integer valued, and minimum is always less than or equal to maximum. So, that means y 1 and y 2 both have to be natural numbers. So, this means y 1 y 2 have to belong to n cross n such that this y 1 has to be less than or equal to y 1 plus y 2. So, that is what you get. So, y 1 is always greater than or equal to 1, less than or equal to y 1 plus 2. So, if you do this, simplify this, this turns out to be y 1 greater than or equal to 1, and this range gives me y 2 greater than or equal to 0. The only thing you have to make sure is y 1 and y 2 both are positive integer valued. So, here you can see the range of y 1 and y 2 do not depend on each other, they can be separated out. So, S y is nothing but for y 1 it is anything positive integer valued greater than or equal to 1, which is n cross y 2 can be anything from 0, 1, 2 and so on. because y1 is less than or equal to y1 plus y2. So, y2 can be anything from greater than or equal to 0. Sorry, I will have to repeat the support of Sy. What is the support of Sy is y1, y2. y1 was minimum of x1, x2, y2 was maximum of x1, x2. Minimum of x1, x2 is y1, maximum of x1, x2 is y1 plus y2. So, what I have to make sure is y1 is greater than or equal to 1, because minimum of x1, x2 is an integer, and maximum of x1, x2 is y1 plus y2. So, y1 plus y2 has to be integer, and y1 plus y2 is greater than or equal to y1. So, y1 plus y2 has to be integer, y1 is integer, so that means y2 is integer. So, y2 has to be greater than or equal to 0. So, this will not be n cross n, this will be z cross z, which is set of integers. So, the support turns out to be n cross 0, 1, 2 and so on. So, for y belonging to y1, y2, y is equal to y1, y2, which belongs to support of Sy, let us look at what is the joint probability mass function at point phi. So, which is same as probability y1 is equal to y1, y2 is equal to y2, which is same as minimum x1, x2 is equal to y1, maximum of x1, x2 is same as y1 plus y2, because y2 is nothing but maximum x1, x2 minus minimum x1, x2. So, y2 is same as saying that maximum of x1, x2 is same as y2 plus minimum of x1, x2. But minimum of x1, x2 has been fixed at y1. So, this is same as maximum of x1, x2 is same as y1 plus y2. So, I again apply the theorem of total probability on x1 less than x2, x1 is equal to x2 and x1 greater than x2. So, if x1 is less than x2, minimum I know is x1. So, this x1 is same as y1, maximum is same as x2. So, x2 is y1 plus y2. Then x1 is equal to x2. In this case, minimum of x1, x2 is same as x1, I can write down, x1 is y1, maximum of x1, x2 is also same as x1, which is same as y1 plus y2, and x1 is same as x2. Then x1 greater than x2, in this case, minimum is x2, so x2 is equal to y1, maximum is x1, so x1 is equal to y1 plus y2. So, this one. Now, again, I use the fact that x1, x2 has the same distribution as x2, x1. Then the last term turns out to be the same as the first term, as it happened in the earlier assertions. So, this turns out to be 2 times probability x1 is equal to y1, x2 is equal to y1 plus y2, x1 less than x2 times this probability, which is probability x1 is equal to y1, x1 is equal to y1 plus y2, and x1 is equal to x2. Now, here note that my y2 can be 0 also. If y2 is 0, then x1 is same as x2, and then x1 is equal to x2 and x1 less than x2 cannot happen simultaneously. So, this probability would be 0. So, that means the case y2 is equal to 0, I will have to consider separately, and y2 is equal to 1, 2, so on separately. So, for y2 is equal to 0, let us see what happens. For y2 is equal to 0, this will not contribute anything. So, only this term will contribute. y2 is equal to 0 will give me probability that x1 is equal to y1, which is same as x2. So, this is what y1 is equal to 0 gives. Because of independent, this is same as probability x1 is equal to y1 multiplied by probability x2 is equal to y1. Now, since both are same, theta times 1 minus theta to power y1 minus 1, this will be same as this. Now, for y2 to be positive integer valued, the first term would contribute and the second term will not contribute, because if y2 is bigger than or equal to 1, then x1 is y1 plus y2 and x1 is equal to y1 cannot happen simultaneously. So, this probability would be 0 and you get only this probability. So, that is why for y2 is equal to 1, 2, so on, f5y is same as 2 times probability x1 is equal to y1, x2 is equal to y1 plus y2. Because of independence, again this is same as 2 times probability x1 is equal to y1 multiplied by x2 is equal to y1 plus y2. Multiply the 2, you get this quantity. So, you have got the joint probability mass function of y1 and y2. Now, here you can easily conclude that y1 and y2 are independent, because you can see in the range also, the range do not depend on each other. The range of y1 can be separated out from range of y2. In the functional form also, the terms of y1 and y2 can be separated out, because they can be written as 2 theta square 1 minus theta to power twice y1 minus 2 times 1 minus theta to power 2 y2. So, here also they can be separated out. So, this suggests that y1 and y2 are independent just through observation. Otherwise, you can easily verify that f y y is same as f y y1, f y2 y2. So, thus y1 and y2 are independent. Now, from this joint probability mass function of y1 y2, I can find out the marginal of y1, which we have already done directly earlier. Now, I try to use the joint probability mass function of y1 y2 to find the marginal of y1. So, what I have to do is I have to sum out the unwanted variable. So, I have to sum over y2 such that y1 y2 belongs to S phi. But here y2 can go from 0 to infinity, such that for any y1 from 1 to 2, y2 can go from 0 to infinity. In that case, y1 y2 would always be in S phi. So, this is same as 2 theta square 1 minus theta 2 y1 plus y2 minus 2. Again a geometric series, sum it, you get this quantity. So, my f y1 turns out to be theta 2 minus theta 1 minus theta to power 2 y1 minus 2 if y is 1 2 so on and 0 otherwise. Now, similarly, one can get the marginal of y2. So, for y2 belonging to 0 1 2, I have to get marginal of y2 from joint PMF of y1 y2. So, in this case I sum out the unwanted variable which is y1. So, I have to sum over all y1 such that y1 y2 belongs to S phi. Now, in this case y1 I know for y2 is equal to 0, I know that y1 can go from 1 to infinity, which is this quantity. For y2 is equal to 1 to so on, it can go from this, y1 can go from 1 to infinity, which is this quantity. So, you get f y2 y2 as this. Very simple exercise to verify. I am not explaining each and every step, but this straightforward calculations.